Okay, so hello everyone. Uh, I am Miroslav Popovic. I'm currently employed at Seavus at the position of technical lead in Microsoft division. You can also find me on Twitter. Here's my Twitter handle on the top, on the bottom right side, and also my blog. Today I will going to talk about building an out microservice with ASP.NET Core Identity and Identity Server 4. So how did this presentation came into existing? So I have worked with authentication authorization for quite some time. I have consulted several clients before when implementing the single sign-on system with them. And also I have been working with Identity Server for recently, and also attended a workshop by one of the authors of Identity Server 4, Dominic Bayer, which was held a month ago as a part of NDC Oslo conference. So this is just some kind of summarize. I also want to create a workshop based on this topic, but this is just a small summary about what's related to actually building the authentication authorization server inside ASP.NET Core. So this is agenda of today's talk, and we'll first go through introduction and then work out some terminologies, etc. So the first thing, why do we actually need to have some centralized authentication service? So this is how most of modern applications or most modern solutions look like today. So we have a complex system made of several different applications, different APIs. Most of them can be made using different technologies and different ecosystems. And we need some way to actually protect the communication between all of these systems and also protect access to the resource which user can give to one system or another. So in order to do that, since we don't want to have a implementation of security, authentication, authorization in all of these systems separately, we want to have some standard way of doing that, and if possible, we want to have a cross-platform standard way. So we'll just use what's currently available as an authorization and authentication solution, and that's OAuth 2.0 for authorization and OpenID Connect for authentication. And we'll have a central security token service or out service, which will actually be used to perform authentication, single sign-on, then to also do authentication federation. So it can be a center site for all the authentication needs. It can connect from other social security sites, logins like Google, Facebook, etc., and also can issue tokens to the clients that need to access some resources. So the problems that we need to solve are authentication, authorization. We need to protect those resources, and we need a centralized solution for that to avoid having different implementations scattered all over our solution. And yeah, like I said, we're going to use OAuth 2.0 and OpenID Connect. We'll also base our central solution on ASP.NET Core Identity. And on top of that, we'll add Identity Server 4 middleware, which will be used for issuing tokens, actually. So what are OAuth 2.0 and OpenID Connect? So those are standards currently for authorization and authentication. OAuth 2.0 is an authorization standard. It's used to grant access to some resource or data and features from one application to another. OpenID Connect, on the other hand, handles authentication. It handles login and can provide profile information about users. Before these standards, there were a lot of other implementations The most recent ones, which predates these standards, are OAuth 1.0 and OpenID. Both of those were pretty complex to implement, and probably some of you remember how they looked like. On the both client and server side, you needed to do a lot more coding to actually enable this functionality. There was a requirement to use some strong encryption on both sides, on client and server side. And the problem with that is that it does not play well with current ecosystem of solutions that we need. It doesn't play well with native devices, with SPA applications, or with smart devices like smart TVs, etc. So in order to enable secure environment for all of those platforms, OAuth 2.0 was introduced for to handle authorization logic. And on top of it, some time later, OpenID Connect was implemented. So it's basically just another layer on top of OAuth 2.0. So this solution that we are building is kind of a playground. So you'll be able to find it on my GitHub account under under a repository, a separate repository for this. I'll have the link at the end of the talk. And it's basically intended to serve as a playground for testing new capabilities, for testing various clients for accessing the centralized solution, etc. And the centralized solution is created as an ASP.NET Core application, and ASP.NET Core Identity is used for managing users' passwords, profile data, and roles. Why ASP.NET Core Identity? Well, because I'm using it all the time in most of my applications for handling all of these identity logic for the users and passwords. It also has a solid persistence mechanism using Entity Framework Core. It has some predefined UI using Bootstrap CSS framework for login, register, forgot password, and two-factor authentication, reset password, etc. It also enables you to scaffold UI elements or pages and override those predefined ones. And it has supports for external logins like Google, Facebook, etc. And the next thing is Identity Server 4. So Identity Server 4 is for a server which protects your resources. It's built as ASP.NET Core middleware, and you can just add it to any ASP.NET Core application, enable it to actually generate tokens for clients to use for accessing resources. It can also, same as ASP.NET Core Identity, authenticate users using some local account store or via external identity provider. It also provides session management and can be used as a single sign-on server for multiple applications. It also manages and authenticates clients. We'll see later what clients really are in this context. And also it has an ability to issue any type of tokens to clients and validate those tokens. So basically, we could use some custom data storage mechanism and UI for logging, registering, etc. with Identity Server without using ASP.NET Core Identity. But since I have already used to Identity and it provides a good set of functionality out of the box, I just chosen to implement it like this. And Identity Server 4 doesn't have any problem with using ASP.NET Core Identity below it. So let's jump through some terminology. So basically, the diagram on the right side shows how this centralized solution works. So on one side, we have users, which goes through some client to get to the resources that it needs. And clients use Identity Server on out service to actually authenticate those users and to get tokens used to access those resources. So in a diagram that we saw on at the start of presentation, those four things at the right side are actually resources. So those are web APIs or web applications, which some other machine or user needs to access. So we have in here we have four resources. Those four things circled now are actually clients. So clients access resources and clients need to be authorized to do so. And also we have two types of resources, which I forgot to mention. We have identity resources, which are just some claims about the user, like user ID, name, and email. And we have API resources, which is a functionality that the client needs to access. Okay, so clients need to be authorized, and users in this case are resource owners. So resource owners gives permission to clients to access some resource on their behalf. So that's basically what OAuth stands for. Also, beside the carbon-based life forms, which are users, persons, we also have silicon-based life forms in this, which are server applications. So it's possible that some application accesses some API without user intervention. Okay, some other terms that you can run into when working in this context. So a claim is one piece of information. You'll see later how token can contain many claims. Scope is something that you want to protect and that the client wants to access. We have tokens, actually several different tokens, which are important. We have access tokens, identity tokens, refresh tokens. Access tokens are actually also called bearer tokens, and they contain information and are used to authorize access to some API. They are their lifetime is very short, so about an hour or something like that, depending on the system which it implements. Yeah, they are used all the time. They are sent on each request to the API. On the other hand, we have identity tokens, which were added by OpenID Connect. Identity tokens contain some claims about the user, and they're basically the result of authentication process. So those are one-time use tokens and can be safely discarded once you get the data from them. And at the end, we have refresh tokens. So refresh tokens are used together with access tokens to enable a longer period of validity for user authentication. So for instance, access tokens, a lifetime of them is about 1 hour, and refresh tokens can have a lifetime of 1 day. So whenever access token expires, the client can use refresh token to get the new access token without asking the user to enter their credentials again. And when we are talking about tokens in OAuth 2.0 world and OpenID Connect, JSON Web Tokens are the most used type of tokens, and they're basically containing three parts. One of them is actually a collection of claims for the users, which is called payload. Okay, and the last thing to talk about here are the grant types or flows. When OpenID, when OAuth 2.0 was first introduced, it came with several different flows, which depended actually on the client type. So there were flows to use when running native applications, flow to use for web applications, for applications without user interaction, etc. And during this period, we got some new recommendations, some old ones became obsolete. And now we basically differentiate two different types of flows. We have non-interactive and interactive flows. So non-interactives are the ones which do not require user interaction. So the only flow currently used for that is client credentials flow. Basically, client can just send the ID and secret to the authorization server and get back the access token. So it's just one request to get the access token. On the other hand, we have authorization code flow, which is currently with PXE protection, which is currently the most used and more or less the only suggested type of flow to use when working with OAuth 2.0 and OpenID Connect. And also on top of that flow, we have device flow for devices which do not have good input capabilities, like smart TVs or gaming consoles, etc. So let's see how the authorization code flow works. So this flow has several requests and responses. So the first step is the client will call the authorize endpoint on the authorization server, giving it the client ID and redirect URL. The authorization server will then ask the user to enter their credentials, authenticate, and give access to the client. And it will call back the client using the redirect URL given to it. And also in that callback, it will give the authorization code to the client. So this code is just a one-time random thing. And the client does not store it anywhere, but uses the back channel. So the first two steps were done using front channel, browser to server communication. And now the back channel, the server side of client application, is sending that code to the authorization server to get the access token. So access token is never exchanged on the insecure front channel, but only on the back channel. So one problem with this flow was with stealing this authorization code on step 2. So if someone can intercept this call, he could just take that code and send a request on back channel to get the access token and use that to access resources on behalf of user. In order to prevent that, a proof key for code exchange, or PXE for short, is added. So PXE is basically a random number which is hashed and sent as code challenge in the first step. So this is the last argument that we have in the authorize call. Then when sending the code on the back channel on step 3, we also send the unhashed plain version of that verifier to the authorization server, so it can be sure that both back channel and front channel came from the same client and they were not intercepted from the man in the middle. So that's how it prevents spoofing or stealing the access to resources. And basically this flow is now recommended for almost or any type of interactive authentication. Okay, so now we go to the demo. So this is basically the structure of the application, of the demo application that we have. So we have a out service at the top. So this is the central service which is built using ASP.NET Core Identity and Identity Server. It's used to define clients in there, to get client ID and client secret and used in any type of client. It also is used for authentication, for user authentication to get the identity token. And also all the clients, and we have several, are used the out service to get the access token to access the protected resource, which in this case are the weather API and weather summary API. Weather API is just a plain, simple ASP.NET Core API, which you get when you create a new project with the type of API. It just has one endpoint to return some random weather information. And we also have weather summary API, which I created to kind of simulate what happens when one API calls another API and passes the access token through them. Weather Summary API just calls Weather API to get some random weather information and also returns a summary of that information, like minimum and maximum temperature. Out of these clients, we'll see how MVC client works. And the rest of them you can check in the source code. I'll leave the link at the end of the presentation. So the authorization server, like I mentioned before, is built as a new ASP.NET Core project with ASP.NET Core identity. And on top of that, I have implemented some best practices to complete kind of that login part. So two-factor authentication is implemented, and actually, whenever you create new ASP.NET Core identity and you want to use two-factor authentication, you need to include another JavaScript library that actually generates QR code on the 2FA page. I have also implemented the email service, which has default non-operational implementation, and it's now implemented using MailKit, which is an open source library for sending email or for anything related to email. And I have also extended identity user to have a profile image, so kind of avatar, just to show that how can we add more data to the existing claims for the user. And also this ASP.NET Core project supports external services. Here I have enabled Google and identity server demo. So we'll see how that works. And on top of that, I have added the identity server for ASP.NET Identity NuGet package. How that is added, I have configured the startup. So in startup, you need to add all the services necessary for dependency injection of identity server. You also need to add middleware in the pipeline. You need to define resources and clients to use. By default, you can add them as in-memory resources and clients, but I have also went through and migrate those to the database and added the full-blown administration interface to actually manage those, to see all the clients available, to add new ones, manage resources, etc. Also, what's changed, new pages were added to the solution. I have added the consent page, which is the one you see on the right side, and also the device authorization page. So the consent page is the page that is displayed after you successfully log in. And it basically asks you if you want to allow the client to access some resources on your behalf and which one of those you want to allow. So by default, some of them are required and some of them you can uncheck. But if you uncheck, of course, you won't be able to access the resources which require those scopes. Okay, and once you start this out service, you'll have this .well-known OpenID configuration endpoint, which returns a JSON document containing all the other endpoints that you can call, like token endpoint, validation endpoint, etc., and also the claim scopes and everything that's supported by the identity server. So let's see how that looks like in code. And let's open this. So in here we have a solution, and the out project is the main one. So this is actually the implementation of the central identity server. And in here, we have add identity server inside the configure services method. It has defined some options, and we also have this in-memory extension methods, which are currently commented since I migrated everything to the database. So in here we have add configuration store, and this is using DB context to actually save those to the database. We also have this line to say to identity server that we have out user from ASP.NET Core identity that we want to use. So this is basically a connection between ASP.NET Core identity and identity server. And we also say that we want to use developer signing credentials, which by default are creating this temp key inside the project, which is used for encrypting the tokens which are generated by identity server. Of course, for production, you wouldn't use this add developer signing credentials, but a full-blown certificate, which can expire, but we'll talk about that later. And yeah, like I mentioned, this is ASP.NET Core, and I have included Google and OpenID Connect as additional providers. And I have middleware defined here, use identity server. So another interesting thing is the config class. So this is a static class containing identity resources, API scopes, API resources, and also list of clients. You can check basically what each client is working and how it's configured. So we have simple clients, which are machine-to-machine non-interactive clients, which are just using client ID and client secret, and client credentials grant type. And we have complex clients like the MVC client, which also have client ID, client secret, has a grant type of authorization code, requires PXE. So this is basically authentication code with PXE. And we also add here require consent. So with this, it will display the consent page to the user. If we put require consent equals false, then that consent page won't be displayed and all the scopes will be automatically used. Okay, require PXE is default from the version 4.0 of identity server. And we also have these few redirect URLs. We have allowed scopes, and we have this which enables us to use refresh tokens. So we must allow offline access if we want to use refresh tokens. Okay. And yeah, this is basically it from the out server side. Now let's take a look at one of the resources, so Weather API. And let's see in startup what it has. So in here, we don't use identity server. We are using just plain ASP.NET Core. So we added authentication, JVT bearer authentication scheme, defined that. Authority is the URL of the authorization server. We have audience defined and some other settings. And also, we just need to use authentication authorization in order to run all that flow. So basically, we're just saying here that to access our API, you need to use bearer authentication scheme and to provide access token in a header. And while there, let's take a look at the MVC client. So in startup of MVC client, we have several things. We also have this add authentication, but this time we have a default scheme of cookies. So cookies are used to just remember user session, and we have challenge scheme of OpenID Connect. So challenge scheme is also defining authority, so the address of authorization server. It defines some other options, client ID, client secret, response types. We also save the tokens which are returned from the authorization server to the HTTP context after a successful authorization. And we also define which scopes we want to use for when authenticating. As an exercise for you, I have this access token management and some extensions on HTTP clients. So those are basically things which are enabled by identity model. Identity model is another library from the same authors as identity server. And you basically are not required, but you can use it whenever you need to access some OAuth 2.0 protected resource. It really helps you do that easily without writing everything down manually, and also it helps with token management. So basically, we are here adding access token management and saying that we want the library to automatically save the tokens when they are added, to add new ones once old one is expired, etc. Okay, and we also have several HTTP clients defined, and all of those HTTP clients will use the token management added before, and get the access token before calling the API. And actual code for calling the APIs is here. We have 3 different methods. One of them is just using the access token, which we get during the authentication phase, and calls the weather API, gets the response. The other one is generating new access token, which is in this case client credentials, which is using client credentials flow, and then also calling the forecast, weather forecast client. And the third one is calling the weather summary client and passes through the access token, same access token as the previous one. Okay, so now let's look how this looks like in the browser. So basically, this is our application, and we can go to MVC client. We can authenticate here, or we can use some third-party service for that. Once we click login, we get the consent page. So you can uncheck all the permissions you don't want to grant to this client, and the client is MVC client, right? And it's written here. So I'll allow everything, and I'm redirected back to MVC client, and it just throws everything that it got from the in the callback from the authorization server. So all the claims, all the properties, and all the tokens. And I have also added this the code token button, which you can use to quickly open JWT.io and get the content of that access token. Same goes for the identity token down below. So ID token is OpenID Connect token. Okay, and here are those 3 methods. So weather forecast 1, which is using that access token we saw now on the home page. Weather forecast 2, which generates new access token and then calls the same API. And summary, which calls API from an API. So basically doing a summary of this. Okay, I won't go through other client types, but you can just click through them and try to, like for instance, this is SPA client where you can log in, call API, etc. We'll just mention them in the presentation. So let's go back here and let's continue. So one of the clients is console client. We also have worker client. So console client just what it does is using client credentials flow. It uses this identity model library to get this well-known document, JSON document, and which I didn't show. So let me just briefly show that. OpenID configuration. So this is the document, and basically this is a standard for OAuth OpenID Connect, and you can just any client, any platform can just use this document to find out what is supported by this authorization server, and can get all the scopes, all the claims, grant types, etc. And also all the endpoints, which is really important. So identity model You just give it the address of the authorization server, and the entity model is capable of getting this document and calling each of these endpoints. So basically, this is what's done from the console client. It just calls that endpoint, gets the access token, then uses that access token to access some API and displays response here. Worker client is for ASP.NET Core worker template, and it basically does the same thing as the console client, but it does it in a loop. MVC client we already saw with all of these three types of accessing, three samples. For SPA client, this is what happens when you call the weather API after you successfully log in. It also uses this authentication code flow with Pixie. And for that, it's using also the OIDC client library, which is a JavaScript library built again by the same people that created identity model and identity server. However, this kind of thing is not really recommended anymore. We have new IETF, which stands for Internet Something Task Force draft. And this draft states that for browser-based applications, you shouldn't really do front-end channel authorization, getting the access token and saving it to the local storage, which basically this client is doing. Instead, you should use BFF architecture, which stands for backend for frontend. And basically that means that you need to have some server-side code which serves your client. And for instance, if you have an API which is only accessed by your SPA application, you just join them together on the same domain. And if you have some API like I have here, weather API, which is accessed by a lot of different types of clients, then you would create a separate backend for frontend for this SPA application, which can basically be just a proxy. So you could use either the proxy kit or Ocelot or this new YARP library, which ASP.NET Core team is working on. So this here is a link, so you can check it out in the presentation later. Okay, and finally, we have this device client, which simulates how the authentication can be handled on the devices which don't have good input methods, like smart TVs, gaming consoles, etc. So it's basically built on top of the authorization code flow with Pixie. And what happens, you probably already saw how this works and looks like. Maybe if you're using Netflix on your smart TV or your PlayStation or something like that, you know, when you need to authenticate Netflix, you get the username and password. When you need to type in your email and password using just a remote control or a gamepad, which is not really best user experience, right? And you also have the Plex, which is a media player, media server and media player, which on the other hand, the application for smart TVs and for PlayStation, for instance, have implemented this device flow. And in there, basically when you try to log in, Plex shows you the link where you can go with your mobile application and even QR code to just scan it and go to that link. And also the code that you need to enter on that URL to authenticate. And when you open this URL in browser, whether on your laptop or on your mobile device, you just go through regular authentication flow with Pixie. And when it completes, the device client will get the response. It basically just queries the authorization server each second or so and waiting for you to finish the authorization. Once the server says, this code is used to authenticate the user, this user, it will return the authorization code back to the device client and it will close the pop-up in this case for the WPF application. And you can read about that on this RCF 8628 link. Okay. Also, I have mentioned this admin interface for managing all the client's API resource, identity resource in the database. You also have that in the solution. And you have probably noticed that I have run everything using Docker Compose. So basically, each project in the solution has its Docker file. I also have several other things like SQL Server and SMTP server for email, also running in the same swarm a bit. So everything is run using Docker. And one of the things I want to look at, and you can do, is Project Tie from, again, ASP.NET Core team and Kubernetes. So Project Tie basically enables you to work easily with orchestration and containerization of your application. It has an ability to just scan through your application to see which containers the application need and just create and output the configuration for Kubernetes. And also it has a service where you can see the interface, which you can see all the running pods actually in your application. So definitely something to look at. Okay, so let's go through some tips and tricks. The first thing is don't add many claims to access tokens. So access tokens should be as small as possible since you need to send them each time you do API request. Just try to have as little claims as possible in them. And also don't try to include secure data to JSON Web Tokens. JSON Web Tokens are not secure. You can just decode them. They are just base 64 encoded. You can decode and see what claims they do contain. So things like sensitive user information should never be part of those claims. Also, don't store tokens to local storage. That's what we talked about when we mentioned the SPA applications, and use BFF backend for front-end architecture for browser-based apps. You also should use authorization code flow with Pixie. So this one, which we mentioned before, with native apps too. So if you want your native app to be pretty and have a pretty custom login screen where the user can enter their username and password, don't do that. It's not recommended anymore. The recommendation is actually to show the browser, either the browser which is currently default on your system, so Android default browser, iOS default browser, etc., and allow user to enter their credentials in that browser and to redirect back to the native application, since any type of operating system now has the ability to trigger the native app using some custom URL scheme. Another thing to mention is for refresh tokens. So I mentioned earlier how refresh tokens work. So they are good for a day. They are used to get the new access tokens when all the access tokens expire. But for refresh tokens, so since they have a longer period, a longer lifetime, it's best to make them to cancel them as soon as possible. So whenever you use an access token, refresh token, just throw it away and make it invalid and get another one. So that's the default behavior of Identity Server 4. Whenever you use refresh token to get new access token, you'll also get new refresh token, which can then be used to get another access token. So this also helps you with prolonging the time the user does not need to log in again. And also it helps with if in case the refresh token gets intercepted or stolen by someone, they can use it only for a short period of time, and they are invalidated as soon as you use them. You also need to prevent these reply attacks to use tokens more than one time, refresh tokens. So whenever token is used, you just invalidate them. They cannot be used anymore. Okay, identity server can also be used as a federation gateway. And federation gateway means that you could use a number of external providers to allow your users to log in using Google, using Azure Active Directory, using some other Active Directory, using Facebook, etc. And all of those can be collected into one gateway, right? So identity server in that case serves as a federation gateway, and it's a best practice to have an to ask the user to fill the data in when they get a callback from the authorization from the external authorization server. So basically, you don't want to trust Google that it will always return the username in the format that you expect. If that's not the case, just ask the user, give them another page once they successfully log in into Google and get redirected back to your application, ask them for additional data to fill in. Use identity model library for .NET clients. That's what I already mentioned. And also at the beginning, I have mentioned that in the demo code, we are using developer key signing credentials, which is for development purposes only. For production, you need to provide a good certificates or other type of keys for signing or encrypting the tokens. And you need to have a good strategy for rotation of those keys. So what happens if they got exposed somewhere, got stolen? And yeah, most likely you'll create an expiration date for them, like they can be valid for a year. And then before that year ends, you can add another encryption key. So both of those encryption keys are served until the old one expires, then you can remove old one. How those will be served? The public keys for those will be available in this JSON document, well-known OpenID configuration, which clients can use to get the new encryption keys. Okay, so at the end, some other things to look at. Like I said, I have some sample admin interface created for this demo application, and it's basically based on this Skoruba admin server 4, identity server 4 template, and yeah, you can check it out on GitHub. There are also other projects, including the identityservers.com admin UI, which is pretty expensive, but also best of all of them. And it can be used to actually do whatever you want with configuring clients, resources, etc. Okay, and other thing to check are the policy or permission servers. So one of them is policyserver.io, which is also another product, paid product of the same guys as that were building the identity server. And why do we need policy or permission servers? Basically, authorization is not the same as authentication. While you can use our identity server to authenticate your users, and to issue tokens. Those tokens should not contain a lot of data, like I mentioned before, about a lot of claims about the user. Those claims can be different for different APIs. So different APIs might need to have, I don't know, some other permission policies, etc., which is basically not the thing that you would add to your identity server. A recommended way is to have a separate server that handles all the policies and permissions, all the authorization logic. And when you use access token and access some API the first time, it can use that access token to check for permissions on the permission server and see what types of functionality are available to that access token. And yeah, we have policyserver.io, and we also have this Balea open source client, which is created this year, I believe. So you can check both. So what comes next? All of these new recommendations for OAuth flows, etc., will be collected together in OAuth 2.1 standard, and that standard will be published sometime in a year or 2 or 3. This is a slow process, and they have already started, IETF already started working on OAuth 3.0. So we can expect more things to come in future for that too. And we have .NET 5 release in November. This is a new version of .NET, the main platform from now on, a new version of .NET Core actually. We are losing the core suffix. We are jumping over the number 4 and going directly to .NET 5. .NET Framework is no more, Mono framework is no more. Everything converges to this new platform. And shortly after the release of .NET 5, we'll also get the release of Identity Server 4 5.0, probably sometime in December, so a month later. And yeah, that's the end. And these are all the references that I used to collect the data for this talk. You have the documentation for both Identity Server and ASP.NET Core. Also take a look at blogs of Dominic Bayer and Brock Allen. Those two guys are the main developers of Identity Server 4. And also, if you had a chance, try to visit one of the trainings or workshop that these guys have. They are excellent, and a lot of things regarding ASP.NET Core and authentications, authorization can be learned from them. Also, you can check YouTube channel of NDC conferences and search for videos from those guys. And there are also some links on for the blog posts on Okta. And this is the link where you can find the sample code for this talk and also this presentation. The presentation is in the root of the repository. So that's it. Thank you. Sorry, the video was not available, but I'm not that pretty, so you haven't missed anything.
Yeah, thank you, Miroslav. Thank you. Great as always. So once again, I want to state that every question that you might have, please write it in the Q&A section, and we will try to answer during the third part Lion Talks. Okay, let's go further. For our next topic, we will hear my colleague Dejan Jakovlevski, who will present the topic of creating progressive web applications. We will hear what PWN stands for, what are the benefits that the technology can bring, as well as we to see as how valuable is it and where to use as a solution for our customers. On the presentation, we will see a lot of code, so we will try to build and enable PWA functionality on this event. So do enjoy. Dan, you have the floor.
Thank you, Igor. Hello, everyone. Welcome to my talk about progressive web application and Angular. My name is Dejan Jakovlevski, and I'm a technical lead in Seavus. And today I will talk about what are progressive web applications. We can see, we can compare characteristics between PWA and a native application. And we can see demo, as mentioned Igor, we can try convert Angular application into PWA. We can see what are service workers, and on the end, like a summary, why we should build a progressive web application and when we choose to go native. So let's start. What are progressive web applications? PWA, or progressive web application, is a web application or application written in a web language. That can be a vanilla JavaScript or some other framework, Angular, React. And those application works like a native mobile or desktop applications. They can also access device features. They can use push notifications. They can be added on a device screen. And in contrast with native application, you don't have to download it. So those features is really hard to be implemented with traditional web applications. But with progressive web application is easy because they use modern web browser capabilities and deliver that native application user experience. So it is important that we can progressively enhance any web application, any web page can be transformed into the PWA and feel like a native application. So progressive enhancement is a useful technique that allows web developers to focus on developing the best possible websites while making those sites to work in a different or in a multiple user agents. These are three characteristics for progressive web applications. So PWAs are reliable. The reliability of progressive web application is based on their independence from an internet connection. So they can work offline and providing a stable experience, no matter the quality of the connection. They also are really fast and they can guarantee speed and efficiency, because on the end, speed is crucial for every online business, no matter if it is a store website or if it is a news website. And the third characteristic is engaging. PWA, as I said, they have access to the device features, which makes it able to enrich the user experience and avoid problems with re-engagement. This is a benefit from marketing point of view, because we always want our customers to get back to our applications. And let's say using push notifications brings user back to our application, even the application is not running, is not started. That's why, let's say, the companies can send offers to the customers, can send marketing news and stuff like that. This is the base technology for progressive web applications. So all these things we will see later in a demo. So what we have here on the left side, we have a browser and client. So today's modern browsers almost all support PWA features. Firefox, Chrome, Apple Safari, Windows Edge. And to build a client, we need vanilla JavaScript, as I said, or maybe we can use some framework. In my demo today, I will use Angular framework. On the middle, we have a service worker and manifest. Service worker is a core for progressive web applications. We'll see later how we can configure service worker and how service worker works. And also we can register a channel for push notifications. And of course, if we need a backend, we can use a backend where we can store data. So now let's see one comparison between mobile web usage and native applications. if we take a look at the numbers, we can see that 13% of people spend or use mobile web, and 87% of people they use native applications. So these numbers should not discouraging us, because usually people who use native applications, they usually spend time on a top 3 applications. And with other words, the number of applications that average user install per month, let's say, is 0. And by contrast of this, mobile users visit hundreds sites per month. And that's why progressive web applications are popular. So these are benefits if, let's say, we start with progressive web application. So first benefit is lowering the cost. So we have one team and one technology instead of separate units, separate teams for mobile application on Android or iOS. Another benefit is improving page performance, also improving effectiveness of new users. So let's say letting people to find our application through the browser, it's easier than asking people to go in App Store to search for application, download, install, and stuff like that. So next benefit is higher user engagement, which translates into an increase in conversions and decrease in bounce rate. Also, we can avoid the problems related to mobile applications. So this is usually related to the process of, let's say, waiting for approval, waiting for confirmation when we build, let's say, mobile application. Also, when we have a new update, we also need to go through the same steps, confirmation, improvement, etc. And on the end, we can integrate our application with any existing or new data source or backend, let's say like that. So the companies or brands that launch progressive web application, they saw impressive results. So I will share the numbers about a Twitter application. So Twitter wanted to improve their mobile web experience, and they decided to create a Twitter Lite. That was happened 2 years ago, and they saw really impressive results. Let's say the size of progressive web application now is 600 kilobytes. If we see the numbers of iOS application, the size of the iOS application or Android, it is a really good result. They also increase the pages per session on about 65%, and also about 75% they increase the tweets sent, and also average load time of the is reduced by over 30%. So now let's see the demo, and we can see all these features, how we can convert existing Angular application. So I can use a command to register service worker to an existing application. But let's say if you want to start from scratch, you can use through the CLI, of course, you can use known command for creating Angular application, and you can end with -- service worker, which will register service worker from scratch. We can see work offline. We can configure service worker, and we can see cache strategy. We can install application on a desktop. I will show you the Lighthouse. This is the really useful tool, actually Chrome extension, and can be used, can be installed on a Chrome, or if you want, you can use through the console. Can be installed through the Node package module. And we can see example how we can notify user when new update is available. And on the end, we can see example for push notification. So now I will go in a code in my Visual Studio Code. So here I have a normal Angular application, and I use one server where I get a list of employees from dummy REST API. And if I run the application, we can see the result presented here in the table. So nothing special, pretty simple Angular application. So now if I open develop tool, and let's say if I switch network to offline, with this I will simulate offline, and if I refresh the page, I will see information that no internet connection, and practically I cannot use my application. So now let's see what will happen if we register service worker, and I will use, as I said, I will use a command ng add Angular PWA. So this will register all necessary files through the, actually this is the node package module. As we can see, installing packages via npm. And we'll see which files will be added and which files will be updated. So let's wait this to finish. Okay, so let's, if we see console here, we can see that couple of files were created. In assets folder, there were added a couple of icons with different names. Also, Angular JSON and package JSON were updated, as well application model. So now let's see all these files directly in the solution. So here in index HTML, we can see that the manifest file is registered. So what is web manifest? This is simple, let's say, JSON file, which contains all basic data about for our application. So we can specify here a name and short name, and this name will be displayed on a home screen when we add our application. Also, we can specify theme color and background color, and here there is a list of icons, and those icons, as I said, they have different dimensions, different sizes, and when we add our application on a home screen, appropriate icon will be selected and added. Also, if we want, we can add our custom icon, custom logo. So what else? If we take a look application module, we can see that there is one file, ngswworker.js, which is enabled only on production. So that means if we try to find this file in the solution, this file is not does not exist because it is generated automatically when we run build for production. What else here? We have a configuration ngsw config JSON file. This is the configuration for our service worker. So as we can see, the default configuration is asset groups. So here we can specify a caching strategy for assets group, for icons, for other files from our application. So install mode determines how those files will be cached. So prefetch there are two values. Prefetch tells a service worker to fetch all resources, all files here and put in a cache. But other possible value here is lazy, which means do not push all files in a cache, just only those files that are requested, which means the files that are not requested will be not added in a cache. And this is the update mode, which determines how those files will be updated when new version of the application is available. So let's now run the application. Because the service workers runs only on a HTTPS, so I cannot test, or actually we cannot test the service worker through the ng serve. So that's why first of all I need to build application for production, and then I will run through the command line HTTP server. So now I will build for production. Build prod, and let's wait application. Let's wait build to finish. Okay, so when build finished, this will create a distribution folder, and inside that folder we will have all files ready to be let's say deployed on a server, and our application can be hosted, let's say like that. So okay, now the build is ready. So here we have a dist folder, distribution folder, and inside we have a PW demo. So now I will navigate there to that folder. And as I said, I will use HTTP server, and we can use a -all, which means open browser immediately, or we can use some specific port. I will try 8088, let's say, and let's see what will happen. So now if I run the application, so as we can see, now we have converted Angular application to progressive web application. So let me open the developer tool now, and if I go here in application, we can see our service worker is registered and is running. And also we can see a manifest file. Actually, this is the content of our manifest file, and these are icons that I explained previously. So what we have now, first of all, if we take a look at this plus button here. So browser itself determines that this application is progressive web application, and gives an option to install our application on a home screen. So if I click this plus button, and if I click install, application will be added on a home screen. So let's add application in a home screen. So if I go here, I will see icon and shortcut for my application. So I can, let's say, continue using application from my home screen. So okay, I will close this, and I will open application again from here, from browser. Okay, so now let's try to switch application again offline. So now if I select offline and if I click refresh, I will see that now application works, but I don't see the remote data. I don't see the data taken from the API. That will be our next step, and we can see how we can configure service worker to cache remote data. Before we proceed on that step, I would like to show you one useful tool. This is the Lighthouse. This is the extension for the Google Chrome, but also can be used through the command line. And this tool, we can measure our application in few categories. We can measure performance, we can measure progressive web application, best practices, search engine optimization, and this application, this tool generates really useful reports. So now I will generate one report. I will select a progressive web application and mobile, and we can check our progressive web application is good enough. So I will click generate report, and this will auditing our application. As we can see, yeah, this is the report for our application. So it is fast and reliable. That is okay. As we can see, we have one remark that does not use HTTPS. So HTTPS is, let's say, mandatory. If we talk about progressive web applications and service workers, and also in the PWA optimized is also there is also a remark about the HTTPS. So really useful extension, and also if you try to use it through the command line, also you can also that can generate a report in a HTML format. So now I will close this tab, and let's regarding the manifest file, I'd like to mention this link. You can read how you can configure manifest, how you can deploy manifest. I'd like to mention that manifest cannot be used for favicons. Favicons should be registered in each HTML files, and also internationalization is not supported through the manifest. So if you need manifest for, if you need that, you need to create a separate manifest for every language, let's say like that. Also, this Angular IO, they have a really good documentation about the service workers. You can read more details how to configure service worker, and I guess you will find useful information here. So let's go back to our code. I will stop the server. Now I will go back to my working folder. So as I said, configuration for service worker, there are two options: assets group. This is the strategy for assets group, and data groups. So I already have data groups here. I will just copy and paste here, and I will explain what is data groups. Here we can specify, of course, we can add a name, which is mandatory in this configuration. Also, we can specify which URLs we want to be added in a cache. I will use my end dummy point from my server, from my service here. And also about the cache config, this is practically a caching strategy. We can specify max size. This is the size of the response that we want to be stored, to be added in a cache. I will specify 1. Max age represents the value of the how long we want that response to stay in a cache. We can specify second, minutes, days, hours, and stuff like that. I will set 1 day. Timeout is related to the we can specify how long our application will wait for response. Let's say if network times out more than 10 seconds, let's say, then service worker will try to get a response from the cache. And strategy can be set to freshness, which means first get data from the network. If network times out, then try to get data from cache. And performance. That means always first try to get the data from the cache. And if a response is not in the cache, try to get data from the from network. Okay, so now I will save those changes, and I will try to build one more time for production, and then we will run the server again and see how this will work. So expected behavior is if we switch offline to see all application functional. So to see the static data, also remote data should be cached and presented in a browser. So now I will navigate to this folder again, PWA demo, and from here I will run my server on the same port. So if I open now the browser, so now I'm online, I will refresh the page, okay, so now if I go here in application, and if I click offline, I will go back online and refresh is needed, obviously. Okay, so now let's switch offline and see our application works fine. So now we are offline, but we are able to see static content, and we are able to see remote data. So with this, we managed to configure service worker to cache remote data. So next, let's say demo I want to present you is how we can notify user when new version is available. Of course, I will use service worker for this. So okay, I will switch back to online, and okay, I will close this browser. I will stop the server again, and I will navigate back to my working folder. So now we are in a working folder. So okay, for this demo, I have code commented here. So I will uncomment it, and I will register here in a constructor. I will register. I will use SW update class from service worker. So private update SW update. Okay, I will also register private push for next demo for push notifications. I will use SW push. Okay, so what we have here. So now, first of all, I check for available updates. So if update is available, I subscribe for that update, and I prompt confirm for user that the new version is available, and I ask user to reload page. So if I click OK, application will be reloaded and I will see a new version on a browser. So for that, so first of all, I need to build one more time for production, and I need to, let's say, deploy this version, apply those changes on a server, and then we can change something in the application, and we will see how this will work. Okay, so now I will one more time build for production, and we will run one more time our server, and this will be just to apply, as I said, those changes on a server, and then we can change something in a application and see how this will work. I hope that everything will be okay. Okay, let's wait this build to finish. Okay, build is ready. So now I will navigate to dist folder and to pwa demo. And from here, I will run server on the same port. Okay, I will open the server and I will refresh just to be sure that those changes are applied on a server. So now I will close the browser. I will close this tab actually, and I will stop the server. I will stop the server and I will navigate to my working folder here, and I will just change the text here. I will write welcome Angular PWA, and I will build this version. And so when this version will be deployed on a server, let's say, so I should see information that there is a new version, and if I click refresh, I should see this welcome Angular PWA, like a new version of my application. So let's wait this to finish. This will finish soon. Okay. So now I will navigate again to this folder, PWA demo, and I will run my server on the same port. I will open the browser, and we see here welcome, because this is the old version, and I see notification for reload that there is a new version. If I click OK, I will see welcome Angular PWA. So all this works through the service worker. So we can see how it's easily, let's say, to deploy, to update, or to notify user with new version. So now I will close the tab again and stop the server, because I will present you how we can use push notifications. So for push notifications, I will use this web push library. So you can find this on a GitHub. There is a good explanation how you can use this library. I will use through the command line, and for that reason I need to register VAPIT keys. But first of all, I will uncomment this code here. So what I have here, I subscribe to my to push messages property, and actually when new message will received, I should see one simple alert with that message. And here, what I have, I just request a subscription. So when user, actually when client is authenticated, I request for subscription, and I write that subscription in a console, because I will use the keys generated from that subscription in my command for sending notification. So first of all, I will copy this web push generate VAPIT keys. It's a shortcut of voluntary application server identification. So I will run this command here to generate public and private key. So I will copy this key here, and I will copy and paste it here. So with this, I'm ready to request a subscription. So how this works? So web push allows one subscription per domain. So that's why I created. So that's why I run application on a, let's say, some special port, just to be able to subscribe to the web push. So now I will go back. I will go back just to one more time to build for production, and I will run again the web server, and I hope that this will subscribe to the web push, and we can see subscription in a console. And when this will finish, we can create a command for sending push notification. So let's wait this to finish. I hope that this will be the last build for today demo. Actually, I will finish with push notifications. Today demo. Okay, great. So now I will navigate to this folder and cdpwa demo. And I will run the server in port 8088. Okay, and I will open the browser, and let me open and refresh. So I need a console. I will refresh the page, and I hope that so here should be written. Okay, you see now I need to allow subscription, because yeah, this is the subscription for my domain, and I can use all this let's say data, and this is the endpoint from where I will send push notifications. Okay, great. And what else? For sending push notifications, you can use this command. So I already have this command here, and I just I will just send. I will just copy data. Let's say this is the endpoint. I will copy endpoint and paste it here. Okay, what else? I will copy the authentication. Okay. I will copy, actually, yeah, I will copy authentication and then the key. This is the key that I need to copy here. Okay. What else? Yeah, this is the payload. This is the payload just simple text, hello Angular PWA. And also Vapid subject is our domain. So this is our domain. I will copy it and paste here. The Vapid public key, this is the key generated here. I will copy, paste the key. And also we need the private key. So I guess that I copy and paste all necessary data on a right place, and then we can just copy this command, and we can paste it here and just execute that command, and we can see that a push message is sent, and our application actually the service worker receive notification, receive message, and we can see that message. So okay, with I finish demo. So now let's get back to our presentation. So now I would say a few words about the service workers. So what are service workers? Service workers are JavaScript file which works in a separate thread than the single browser thread. So actually they are a kind of a proxy between our application and between network. So they're completely independent of the application they are associated with. And this has several consequences. So let's say a local storage cannot be used in a service worker. And also the service worker can receive push notifications even application is not running. And here I'd like to say something that whether notifications are received when the browser itself is not running depends on how browser is integrated with the operating system. So let's say for the desktop browsers, they can receive notifications only if they are running. But for the, let's say for Android is built on that way to wake up browser when there is a new notification. And that's why on a devices, users can see notifications even of regardless of state of application or state of the browser. And another thing I'd like to mention that the service worker cannot access directly to the DOM, so communicate through the post message. I already mentioned the URL from Angular where you can read about service workers, and you can see additional information if you need it. Okay, so like a summary, why we should build progressive web application. If we take a look, if we compare native cross-platform and PWA, so for native cross-platform, we need different builds for each device, for each platform, and that means we need the developer for iOS, developer for Android. And we need, let's say, to code for maintenance. Also, native applications are distributed through the app, through the Play Store. So we need to ask user to go in Play Store to download application, to install application, to allow access and stuff like that. And also, if we have a new update for our application, we need to again, let's say, update, ask user to download and reinstall that update. And the whole process, let's say, is expensive. But what about progressive web application? They build once, they run anywhere. We saw it's easy to deploy, it's easy to update. because they are web application, and the whole process, let's say, is cheap. But yeah, maybe the question is when we choose to go native. We can go native when we have a, let's say, a special requirement for some device hardware feature, like a Bluetooth NFC, or if PWA features are not supported. So I said that modern browsers, almost all browsers support PWA features, but before we decide how to start or to go to start with PWA or native, I'd like to share two useful websites. Maybe you already know about those sites. Let's say what the web can do today. So here I can check which features are supported in my current browser and which features are not supported. Let's say, and based on this, I can decide to start with PWA or to go native, let's say like that. And other useful page is can I use. So here we can specify, let's say, I don't know, if we have a requirement for application to access camera, we can type camera, and we can see which browsers allows that feature, support that feature, and of course we can make a decision. Okay, so yeah, that's I think, yeah, that was the last slide. Yeah, thank you for your attention, for your time.
Thank you, Dan, also for a great presentation. Okay, so now it's time for our third part of the event. So the Lion Talks. I want to present two of my colleagues who will join the presenters in the panel, and we'll try to answer all the questions that you might have. First is my colleague Dan Zrakovski, who is working as a technical lead and .NET developer. And next is my colleague Igor Yoshevsky, who is a technology line manager for front-end technology. So we can start by answering some of your questions that have came in the chat, and we can continue with anyone of you that wants to ask or join the discussion. So please just contact me to unmute you and be part of the discussion. So we would be very glad if many of you will join and contribute, so we could have a great discussion actually. Okay. Okay, are we ready? We can start.
Yep.
Okay, great. So first question came from Milos Stefanovic. What are you thinking about sending roles and permission through token?
Yeah.
So this
okay.
is a question for Miroslav.
Yes, like I already mentioned in the QA section, it really depends. So if those roles and permissions are on the system level, so if all the APIs, if they are usable for all the APIs, like for instance, if someone is admin on the entire system or something like that, or if you have a small number of APIs, then yes, you can also include roles. But if you have more complex APIs or more of them or more complex permission-based system, it would really enlarge the size of the token. And yeah, it's not really recommended to have roles which are specific to just one API to be included in access tokens, which are shared maybe between more of them. So you need to wait in, see what's the best in your case. And one thing to look at are that policy server, which I talked about during the presentation. So that's one of the ways to ensure the policy, permission policy, and to have it separately, or to have the authorization separated from the identity part. Hope that answers the question.
Okay, Milos, I have unmuted you. Want something to add, please go. Okay, so we'll go to the next question. So Johan asked question, is it possible to exchange Windows login credentials stored in Active Directory for an OAuth 2.0 access token? On several occasions, clients ask for website login using Windows credentials without the need to log in anywhere else.
Yes, one of the supported things with Identity Server 4 is Windows authentication, and also Azure Active Directory is supported. I think you mean just Windows on-premise Active Directory. So both of those should be supported, and you can look into the Identity Server documentation. There is a page for specifically for Windows authentication there.
Okay, Johan, do you have something to add or ask even more? Okay, so we'll go to the next question. Andy posted a question. Is there any secure way to authenticate a single page application or a hybrid application using Identity Server 4 without being redirected? So maybe by using Ajax?
Well, for that, there is an implicit flow where you can just enter username and password, but it's not really encouraged anymore. So basically, the best and most secure way for Ajax or SPA applications at the moment is to have some kind of backend for frontend and to have the access token stored in cookie. To have a cookie-based session, basically, which the SPA application can use, and maybe if you need to call some resource server to go to proxy to call that. So that's also one of the things that Milos Slavic asked. And basically, he has some more complex solution he works at the moment with Vue SPA application, with a lot of Ajax call, with Ocelot aggregating all of them, and the tokens are in their case are stored in local storage. And he just asked whether would it be possible to is it okay to store it there, or what else can be done for this? So basically, if you already have a backend for your SPA application, it would be great to just use cookie-based authentication and to have same site cookies and provide the authentication part in that way, and just store the access token either in cookie or make it available from server side only, so it never leaves the server side.
Yeah.
Okay.
Can you hear me well? I believe yes.
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 Yeah. So I will add another approach here, since most of the SPA applications are running under Webpack, which means Node.js. Actually, you can simply add an interceptor on a Node.js site and proxy all the calls from the front end to this Node.js, where on the Node.js side, you can do all the magic, like adding secret tokens for the API communication, keys, I don't know, communicating together OAuth tokens and so on, so on. So later you just return the response to the front end, where the users and any other parties that might interfere with the application are not going to be able anything related to the secrets of the application itself, including this token communication like GVT or something else.
Okay, great. Let me just add that
Okay,
you
great.
can.
And the,
Sorry, just add. You can also Google Dominic Bayer. Spas are dead. He has a really good blog post about. Yeah, it's kind of catchy title, but it has a great blog post of how to actually do browser-based applications in today's world. And it has a link to this IETF recommendation for browser-based apps, both the apps that have a backend and those without backend, which are served from CDN or something like that. So yeah, you can just check it, check those links, and maybe it will be more clear.
Okay, and I will unmute you now if you have something to add. Okay, you are very quiet, so please continue. Join the discussion if you can. You're welcome. Okay, so next is Mirjana, who has a question for Miroslav. It goes like, in the microservice world, is it recommended practice to route each API request with the authorization service API, or is it acceptable to have a JWT token as an example and pass the token between APIs to avoid double hop in each call?
Well, basically, I think that's the scenario that I have covered with one of the samples in the MVC client. So just to use one access token for two different services. In order to do that, you just need to provide both scopes for that token. I hope I have understood you what you mean.
Okay, just a second. Just a second, please. Okay, we'll go to the next question. So next question is by Miloš Slavic. We have a Vue.js single page application.
That one I have already, yeah, we have already talked about that question.
Okay.
Yeah, previously. So.
Yeah. Okay. So you answer it the whole. So okay. So the next, if we have a monolith Netflix 4 application which uses ASP.NET membership provider, how could we transfer to the existing profile and roles to this SPA web API concept that you have explained with identity server? So how easy it is to migrate the old application, for example, with the membership provider, new, let's say, way of doing things?
Well, yeah, with ASP.NET, ASP.NET Core identity, you could just define the classes or actually map to the data that you have previously. The biggest problem with the migration that I also had previously is with migrating passwords. Since passwords are stored as hashes in the database, and the logic for creating those hashes is different. So different algorithms are used in, let's say, ASP.NET Core Identity now than ASP.NET Membership was using earlier. So, but yeah, one great thing about ASP.NET Core Identity is that it's easily extendable. So you can just replace the actual algorithm for generating hashes to match that from the ASP.NET membership. That's actually something that I have already done for one client several years ago when we have migrated from some provider. I don't think it was ASP first version of ASP membership, but something later, simple membership or something like that, to the ASP.NET Core Identity, and yeah, it worked like that. So basically, one thing you can try to keep your structure, and just map into the what ASP.NET Core Identity expects. So you can use any type of data on your identity user. Or another thing, you can just try to migrate the data. So basically have tables which matches the current ASP.NET Core identity properties, and just use some SQL scripts to copy the data from the old tables into the new ones. So two approaches, but the part with password hashes is the most tricky one to get, but it's possible, yes.
Okay, great, thank you. Milos, do you have something to add? You are unmuted now, so. And once again, you are muted. Okay?
Okay, do you hear me now?
Yes, we hear you.
Yes, we hear.
Okay. I don't like cookies, so is there some other way to store this token? Or Igor Yoshevsky mentioned Webpack. We are using Webpack for development at the moment, but in case that we use that kind of proxy for our authentication, should we deploy our application as a Node.js application or just static HTML with all those things? And if you can also share the link with Webpack setup for that.
Yeah, I understand your question. Actually, you'll have to create a Node.js server, which I don't know, uses Express, for example, or if you prefer Core or any other library. The idea is to put the whole bundle from the Vue.js build into, let's say, public folder that will be used as a folder from where static content is going to be served from Node.js side. And it's really easy to be made. And everything you'll have to add is just one middleware that will intercept all the stuff. I will try to find the proper example of that. I'm not sure.
And,
I have a link available. Yeah.
Do you maybe know how is that middleware working? Is it creating some kind of session like that we had on ASP.NET MVC sessions?
No, actually, it doesn't use any session. It will catch all the requests regardless of the session, or are they, let's say, belonging to the user or not. And for each request, it's going to parse what is in the headers and what should be returned back according to the communication with the actual backend. But since the GVT token is going to be provided all the time as a bearer, so the Node.js will be able to take that information from the headers, from the request from the front end, and just pass it later on to the backend as a proxy. I will try to share a link with you for how this works, but maybe in some email or something, because at the moment I don't have the link in hand to share with you, but definitely something I can send later to you.
Okay, you can send me on Seavus email.
Yeah, okay.
Thank you.
Okay, and the last question that I have, maybe I've missed something. Please correct me if I do, if I did. So last question is some thoughts about practical experience about usage of separate Docker containers for hosting the separate components. This, I believe, is to Miroslav.
Okay.
So practical experience about multiple containers containing components, separate components.
Well, in my case, not much practical experience since I just recently started doing containers more than before. But mm, hmm, what can be added for that? I
Yeah,
don't know.
Java developers are more used to use Dockers. Yeah, with .NET
Well,
developers
we
actually are
have,
quite
well, yeah, the Docker
little behind.
enters quite fast into .NET and .NET
Yeah.
Core world. Yeah, we have a lot of tools available. Just recently, we also have whoever does the development on the Windows machine. We have WSL2, a Windows subsystem for Linux part 2. And Docker for desktop is basically running on top of that. We have a lot faster containers. We have this remote development capability built in from Visual Studio Code. So yeah, and we have that project TIE that I mentioned during the presentation, which is still in some kind of alpha version, but it really enables you to jumpstart your entire system using orchestrators on Kubernetes. Kubernetes has kind of a steep learning curve, and basically TIE is built for that, just to enable you to more quickly go into this containerized world. And yeah, I don't know. It kind of is attractive to think about the things in more granular manner, to have microcontainers for most of the things. It definitely helps with that you can use any popular library or framework or some other application from other platforms, not necessarily in Microsoft space, in .NET space. You can just, I don't know, spin the Elasticsearch in one container, spin sec in another for logging. I don't know, Apache Kafka in another one, and combine all of that into one system to use great tools that exist in other platforms, which makes .NET thrive more. So
Yeah.
I think this is a really good topic. I mean, I think we as developers tend to be more and more technology line agnostic these days. So I think we had a good mixture actually of the technology lines, different technology lines we were talking about today. And especially this concept for containerization, as Miroslav mentioned, enables us to like easily spin up any Docker or any other container having different operating system, having different technologies on a single hosting machine, and we don't have these limitations anymore that some technology cannot be run or cannot be executed. It's limited to certain operating systems, certain capabilities, and so on. But on the other hand, I think that separating things more and more, this granularity also includes a high level of complexity in other parts of the engineering process as well. So debugging, for example, becomes a little bit more trickier when you have different components hosted on different places, and when you need to debug an end-to-end flow that goes through all these components, it's not so easy compared to a monolith, for example. And it's also interesting when you need to deploy these components, especially if you would like to automate to some extent, put some continuous delivery process out there that should spin up all these things, that should put everything up and running, upgrade, deploy a new version, and so on and so on. It definitely increases the complexity, and it's out there. We should start using it, but we should also consider it that we not maybe don't tend to over engineering things and stuff if it's not really needed. And I also wanted to mention about that particular previous topic that we discussed. So it basically the middleware, it's again technology line agnostic. It's related to some standardized concepts that Nevertheless, if that middleware is hosted on a node server, or if it's hosted like on a .NET, especially .NET Core hosting components, like some API gateway component or something similar, the concept is important. So even in the days of using cookies, the concept was pretty much the same, with the terms that that cookie was by default sent in each HTTP request, and now we just need to put those tokens in each HTTP request, just put them during the implementation in the header and so on and so on. But we need some proof in order for us to authorize the client, whether that's some like end user that is using the browser, whether that's some service that is trying to communicate with other service and so on and so on. We need some proof of the identity, and there are definitely I think Miroslav covered a lot of possibilities how that can be done, mostly in the .NET world, but I think Igor also mentioned alternatives how that can be done in the JavaScript technology line using node server as well.
Great, thank you. So those were the question actually that I had. So does anybody else has a question?
Igor,
Oh,
I see one question here in a list which is related to the push notifications and the topic that I presented. So the question from Andy: can we receive push notifications when the browser is closed? So I already mentioned that it depends on how browser is integrated with the operating system. Usually for desktop browsers, they can receive notifications only if they're running. But for Android, let's say, Android is designed on that way to wake up browser if there is a new push notification. And that's why on a mobile device, when we are, let's say, when application is closed or we are working something else on our phone, we can see notifications, push notifications, and when we click on that notification, we can bring back to our application, and let's say if it is a PWA, the browser is running and everything works.
Sorry to miss that question. I didn't see it.
No problem. I just checked the list. And so.
Yeah, great. Okay, so once again, if anybody else has some question, we will be much than willing, and we are eager to answer. So, okay, we will wait for 5, 4, 3, 2, 1. Okay, so if there are no questions, I want once again to thank you all for taking some time to be with us today. So I hope that you had a good time spent, and I hope that we will see each other on our next event. So thank you once again, and thank you all for all presenters and participants.
Thank you to everyone. Take care. Bye.
Bye.
Thank you.
Bye.
Bye.